In this lesson, we're going to look at some of the uses for the trig ratios and also how to use our calculators with them. So it's really helpful if you've got your calculator handy right now. And the first thing you need to be able to do with your calculator is decide if it's in degrees or radians mode. So I'll just show you with one of the graphing calculators how you switch between them. If I hit clear on the graphing calculator, notice, and this is the same button for some of the different versions of the calculators as well. If I click on mode and I scroll down here, you'll see that degrees is one of the options. So if I need to go down to radians and degrees, so I highlight it, press enter, and now it's in degree mode. And then second quit brings me back to the cleared screen so I can start to use the calculator. On many scientific calculators, there is a button with DRG on it, and that stands for degrees, radians, and gradians, another way of measuring angles, which we won't be using, but that button is there for on a lot of the calculators. So make sure that you can switch between them. The other thing you need to check is your calculator a frontwards one or a backwards one? And by that I mean, do you press the sine, cosine, or tan button first and then the angle? Or do you press, for instance, in this first example here, would you go 50 sine or sine 50? The graphing calculators and most Texas Instrument calculators are what I would call frontwards, where you put the buttons in the order that you see it, but some calculators need to have the angle put in first. So make sure that you know how yours works, and you'll be able to test it as we go through these 6 examples here. Okay? So with your calculator, enter the sine of 50 degrees. So I'm just going to put in sine, if it lets me. Maybe I have to put my pen down. Excuse me just a second while I see if I can figure that out. Just going to hit the clear button here. Okay, I'm not really sure what's happening with the calculator here. For some reason, the sine button doesn't seem to be working, but the cosine button is. So I'm going to try the cosine of 15 degrees. So once I hit the cosine button, you see the cos and the opening brackets, and I'll enter 15. And if I were to do more operations, I would have to close those brackets first. But because all I'm doing is the cosine of 15, it gives me the decimal ratio for every 15-degree angle. This is the ratio of the adjacent to the hypotenuse. We round these numbers off to 4 decimal places. So it'll be 0.95, and now because I'm working on this, it's minimized, 9659. So 0.9659. Okay, and let's go back and try the tangent of 80 degrees. So the tangent of 80, and enter, and I'm getting 5.6713. And let's try the secant of 15 degrees. Notice how there's not a secant button, and the sine to the -1, cosine to the -1, etc., do not give us the reciprocal ratios, okay? They give us the inverse of the sine, so they give us an angle when we know what the sine, cosine, or tangent is. They do not give us the reciprocal functions. So secant is the reciprocal of cosine of 15 degrees. So what I could do is I can do the cosine of 15 degrees. So cosine of 15 degrees, hit enter, and what I want is the reciprocal of that. So I could raise it to the power of -1, for instance, and I'll get 1.03, 1.0353. Okay, there are other buttons depending on the type of calculator you're using, but you could have a button that's called 1 over x is often what it looks like. 1 over x, and that button will give you the reciprocal of whatever number you happen to have in as well. So use one of those two methods. So now let's look at doing sine. Well, in my case, I'm going to do the cosine of pi over 4, and I'm going to do the cotangent of pi over 6. So those are angles in radians. So we need to switch our mode over again. So I'm going to go to mode and go down to radians, hit enter, and now I'm in radians. I can quit that function. Okay, and so now instead of sine here, I'm going to do cosine of pi over 4. So cosine, and now I've lost where I put my pi button. And the screen is not easy to read here. So I'm going to cheat, and I'm going to use 3.14 as my approximation, which I don't like doing. Divided by 4, close the brackets, and I should get 0.7071. So because I approximated my degrees, I'm not quite where I should be. So hopefully you can see on your calculators where your pi button is and actually use the number pi rather than 3.14. If at all possible, do that. Oh, now I see where the pi button is. It's above my exponent button. So I'm going to try that one more time. So cosine of second exponent button divided by 4, close the bracket. There we go, 7.7071. And the sine of pi over 4 will be exactly the same. Okay, and then let's do the cotangent of pi over 6. So remember that, again, that's the reciprocal of the tangent. So I'm going to do that a different way this time. To do the reciprocal, remember it's 1 divided by the number. So I'm going to go 1 divided by, and I'm going to do the tangent of pi over 6. So there's pi divided by 6, close the bracket, and 1.7321. Okay, we'll spend a few minutes with our calculators in class as well, just to ensure that everybody's got that working for them. Okay, now a couple of a definition here that we need, and I'm just going to go full screen. The angle of elevation means we're going up from the horizontal. So whenever you see the term angle of elevation or angle of depression, always think, where's the horizon? And then think up for angle of elevation or down for angle of depression, okay? So we're going to look at this question, and in trig questions, you always want to draw a picture. It doesn't necessarily have to have a lot of details in it, but you want to see the right triangle that is the picture of the problem, okay? So your height is 1.72 meters. You observe a tree that is 7.2 meters away. the angle of elevation of the top of your head to the top of the tree is 31 degrees. How tall is the tree? So we always make the assumption that our ground is horizontal. So here's the tree, and you can sketch in a tree if you want, okay? And here's you, okay? And your height is 1.72 meters, okay? Now, when you look up at the tree from the top of your head, okay, you're looking up from the horizon because it's an angle of elevation at an angle of 31 degrees. And your horizontal distance from the tree is 7.2 meters. So here is your right triangle. I'm going to just put it in solid lines here. There's the right triangle. Okay, so we know the 7.2. Okay, and we know the 31 degrees and we know the right angle of that triangle. So now we want to find the height of the tree. So really, we can find this distance. So let's call that distance h. Okay, now let's take a look at the right triangle here. There's my hypotenuse. H, the length that I want is across from the angle, so it's the opposite. And the 7.2 is the adjacent. So here's how we use our trig ratios. We think about the value that we want to find. So it's the opposite, and we look at the value or values that we've been given. Notice that what we've been given is the adjacent. So I'm going to use the trig ratio that uses the opposite and the adjacent. So that will be the tangent. So the tangent of 31 degrees is equal to h, my opposite, over 7.2. Okay, so we just write out what the ratio is. Now we can use, we want to isolate h, get it by itself. So if I look at this, I can just multiply both sides of the equation by 7.2. So h will be 7.2 times the tangent of 31 degrees. So try that on your calculator. Press pause a second if you need to, and see if you get the same result that I do. And once we've played with our calculators, we get that h is 4.3 meters. Okay, now h is not the full height of the tree. Okay, we need to add to that height the height from the ground that we were measuring from, because remember the angle of elevation is from the horizontal there. So we still need to add 1.72 meters to that value of h to get the full height of the tree. Okay, so 4.3 plus 1.72 will give me 6.02, I believe. So the tree is 6.02 meters tall. In this question, we're being asked to solve the triangle. Solving a triangle means finding all of the missing sides and angles. Okay, so let's label the missing sides and angles with letters so that we can do that. So if we call this angle A, we could call this side A since it's across from there, and we could call this side B. Notice that the angle has a capital and the sides have lowercase letters. All right, let's start with angle A. We can use a property of triangles that states that all the angles in a triangle add up to 180 degrees. So angle A will be 180 minus the 90 for that angle, minus the 27 for that angle. So that will be 90 minus 27, 63 degrees. Okay, so we've solved for one of our three missing pieces. So now let's look at side A. We know angle 27, so we'll use that as our reference angle. And now let's label our three sides for our trig ratios. Side B is our hypotenuse. The 7.6 is our opposite because it's across from the angle, and side A is our adjacent. Okay, so let's solve for side A first. We know the opposite, we want the adjacent. Opposite and adjacent is the tangent, so we can say that the tan of 27 degrees is equal to 7.6 over A. Now we want to solve for A. In order to do that, we need to do the quickest way to think of it would be to put a 1 under here and recognize that as a proportion where we can cross multiply. So we could say that A times the tangent of 27 degrees is equal to 1 times 7.6. But then to get A by itself, we would divide by the tangent of 27 degrees. So A is 7.6 divided by the tangent of 27 degrees. And if you want to see how that switcheroo happened in greater detail, we can discuss that in class. So now, with your calculator, you can just, and make sure that you're in degrees mode here, we can just go 7.6 divided by the tangent of 27 degrees, and we get 14.9. Generally, we round our sides to one decimal place, and when we're solving for a missing angle, we round to the nearest whole number for degree angles. Okay, so now we need one more. We know side A, we know the 7.6, and we need this side. There's two ways to do that. We could use a trig ratio to do it, but now that we have this right triangle and we know two sides, it's probably easier to use Pythagorean theorem for it. Okay, so we could say that b squared is equal to 7.6 squared plus 14.9 squared. So b squared is equal to 279.77. So b is the square root of that. Which gives us 16.7. Okay, that triangle is solved now. All the angles and all the sides are known. Our next question, the infamous ladder question. We have a 6-foot ladder leaning against the wall at an angle of 72 degrees. So how far is the base of the ladder from the wall, and how high up the wall does the ladder go? So again, very helpful to draw a picture. Here's the ground, here's our wall, here's our 6-foot ladder. And we put a right angle there between the ground and the wall, recognizing that walls are perpendicular. And that's an assumption that we make. Okay, so the ladder is 6 feet long. It's at an angle of 72 degrees with the ground. And we want to find the distance of the base of the ladder from the wall. So that's this distance across here. And we want to find out how far up the wall it goes. Okay, so let's take a look at our trig ratios again. And you might want to just try this on your own and see if you can figure it out. So press pause and then see if yours matches. Okay? For the triangle, I'm going to label the three sides. So 6 is my hypotenuse. For that 72 degrees, y is the opposite, and x is my adjacent. So to solve for x is the adjacent, And the 6, the other value that I know, is my hypotenuse. So adjacent and hypotenuse is cosine. So the cosine of 72 degrees is equal to x over 6. To get x by itself, I'm going to multiply both sides by 6. So we'll have 6 times the cosine of 72 degrees, which is 1.85. Oh, well, sorry, I said 1 decimal place, so we'll round that to 1.9 feet away. Okay, and then we want to calculate how far up the wall it goes. And again, we have a couple of options here. Because we know 2 of the sides, we could use Pythagorean theorem, but I'm going to use a trig ratio to do it. Y is the opposite, and 6 is the hypotenuse. Opposite and hypotenuse gives me sine. So the sine of 72 degrees is equal to y over 6. So, and again, I'm just going to rearrange that equation like I did the previous one. So y becomes 6 times the sine of 72 degrees. And we get 5.71 or 5.7 feet. Okay, so that was using a trig ratio. And I actually like this method of finding the second missing side better, because notice in this question with the second part, I still used only values that I was given. Whereas in the previous question, when I solved for the missing side, I used a value that I had calculated. So there's less chance of making a mistake here, and I'm not using a rounded value to get this answer. So I prefer this method. This last question is partly a graphing calculator, sorry, not a graphing calculator, but a calculator skill. But here I know 2 sides of the right triangle, so I could find the third side using Pythagorean theorem, but I haven't been given any of the angles besides the right angle. So we can use our calculators to find the third side. So there's my hypotenuse, which I don't know yet. The 7 is my opposite. The 12 is my adjacent. So I know a full trig ratio because I know that I've got opposite and adjacent, which is tangent. So I can say that the tangent of angle theta is equal to 7/12. So that's a constant, just a number. So to find the angle that has this tangent, we use the inverse. So theta is equal to, and we say the tan inverse, or the inverse tan is the correct way of saying it, but it's the inverse tan of the ratio 7/12. So do that on your calculators, okay, to find theta. So on the graphing calculators or frontwards calculator, you'll just go second tan, and in the brackets do 7 divided by 12. This time do close the bracket after the last number so that you're sure of getting the whole ratio as that you're doing the tangent of, or the inverse tan of, and you get 30 degrees, or 30.256 degrees. Do the sine inverse, or the inverse sine of 0.7071. If your calculator is in degree mode, you should be getting 45 degrees. Okay, so we can enter in the ratio and get the angle as well by using, on it, almost every calculator is going to be second sine, okay, to get the inverse function of that.